All right, please, let's look up. Now, we've seen the steps, the 3 steps involved in beta oxidation. Now, let's look at the energy yield from beta oxidation. Let me ask you a question. If you have 100 grams of butter and you have 100 grams of, let's say, rice, carbohydrate giving food, which one gives you more energy? You know that lipids give more energy than carbohydrate, right? So this one will give you more energy than carbohydrates. So lipids give more energy than carbohydrates. Let's see how the energy is given. So let's look at the energy yield from beta oxidation. We've seen that beta oxidation is the process of breakdown of what? Fatty acid, right? Breakdown of fatty acid. And we say this beta oxidation takes place where? In the mitochondria. But the first step takes place where? Cytosol. Now, to illustrate this, I'll use one fatty acid. Let's start with palmitic acid. Now, palmitic acid have how many carbon? Please listen up. Palmitic acid have how many carbon? 16 carbon, right? Remember the acronym I gave yesterday. Lord, my palm says around liberty. Lord, my palm. That's the third one, right? 12, 14, 16, right? Good. Now, palmitic acid is 16 carbon. Now, if we want to break down this palmitic acid, you agree with me that the first step will be activation of palmitic acid. Activation of palmitic acid to what? To what? Palmitoic-CoA. So let's look at the process before we see the energy yield. Palmitoic-CoA. Now the palmitoic-CoA will now be transported from the cytosol into the mitochondria, right? Using carnitine transport. Now, once the palmitoic-CoA gets into the mitochondria, say the palmitoic-CoA, carnitine will leave it, right? So let's just know now that the palmitoic-CoA is into the mitochondria. Beta oxidation can now take place. And in beta oxidation, we said this palmitoic-CoA, the palmitoic-CoA here, will undergo first oxidation by what? Oxidation by what? FAD, right? Introducing a double bond to form what? To form trans what? Delta 2 what? Enoic-CoA. Because double bond is introduced between carbon 2 and carbon 3. Now, after that, after oxidation by FAD, the next step is what? Hydration, right? This enoic-CoA will undergo hydration. That's addition of water, right? And hydrogen will be added on one side of the bond. OH will be added on the other side of the bond, right? On the beta carbon. To form what? Beta hydroxy what? Acyl-CoA. Now we said this beta hydroxy acyl-CoA. You said number 4. Beta hydroxy acyl-CoA will undergo another set of oxidation by what? NAD. So the OH now on the beta carbon will be oxidized to what? Ketone, right? To form what? Beta keto acyl-CoA. Now after this, the last step is cleavage, right? To form what? So the last step, beta keto acyl-CoA will be broken, right? To form two things. Acetyl-CoA and acyl-CoA, right? Acyl-CoA that is short by how many carbon? 2 carbon, right? So since we started with palmitoic-CoA, if you are removing 2 carbon from palmitoic-CoA, what are we going to have? Myristoric-CoA, right? So here we have myristoyl-CoA. Then this myristoyl-CoA will undergo another set of beta oxidation, and 2 carbon will be released in the form of what? Acetyl-CoA. How many fatty acyl-CoA? How many carbon fatty acyl-CoA are we going to have left? 12, which is what? Lauric acid. It will undergo like that. 2 will be removed like that until we remove all in form of what? Acetyl-CoA. The end product of beta oxidation is what? Acetyl-CoA. Now you observe with me that you observe with me that we are removing the carbon in 2s, right? Now, if palmitic acid have 16 carbon, how many rounds of beta oxidation will this thing undergo? 8 rounds. Are you sure? How many? Wait, listen up. How many rounds? How many rounds? It's a lie. 7 rounds, right? 7 rounds. Let's look at it. Let's look at it now. Not be how. Look at this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 carbon, right? Then we remove the first. This is the first round, right? Acetyl-CoA is giving up. 1, 2. This is the second round, right? Another acetyl-CoA. 3rd round, 4th round, 5th round, 6th round, 7th round. This one remaining is already acetyl-CoA. So you see that how many rounds do we have? But how many acetyl-CoA did we produce? 1, 2, 3, 4, 5, 6, 7, 8. So 8 acetyl-CoA, but 7 rounds. Do you understand? Now, if it is 8 acetyl-CoA, if you look at this very well, you agree with me that in each of the round we were using FAD, right? And you agree that FAD is supposed to be FAD2 plus, will always be reduced to what? FADH2, right? So each round we were producing 1 FADH2, is it not? So how many rounds did we take? 7 rounds. So how many FADH2 did we produce? 7 FADH2, right? So we produce 7 FADH2. In each round too, we were producing NADH, right? So how many NADH did we produce? All 2. So we produce 7 NADH. Is that understood? But you agree with me also that we have 8 acetyl-CoA, right? Acetyl-CoA, the acetyl-CoA produced will go into the TCA cycle. And hope we still remember the TCA cycle. Acetyl-CoA will condense with oxaloacetate to form what? Citrate. From citrate to isocitrate, isocitrate to what? Alpha ketoglutarate, alpha ketoglutarate to succinate, succinate to fumarate, fumarate to malate, malate back to oxaloacetate. If you've forgotten that, go to my channel. You'll see it there. And when you get to my channel, what's the first thing you do? You subscribe. Alright, so now if you calculate the energy yield for 1 acetyl-CoA in the TCA cycle, which I'm not going to go into, 1 acetyl-CoA molecule in the TCA cycle will generate 12 ATPs. Will generate how many? 12 ATPs. And we are aware that 1 FADH2 will generate how many ATP? 2 ATPs. 1 NADH will give us how many ATPs? 3 ATPs. Now let's look at this. How many ATP did we produce? Sorry, how many acetyl-CoA did we produce? 8, right? Now if we produce 8 acetyl-CoA and 1 acetyl-CoA is giving us 12 ATPs, 8 acetyl-CoA will give us how many ATPs? Please let me use this 8 acetyl-CoA. If 1 acetyl-CoA is giving us 12 ATPs, 8 acetyl-CoA will give us how many? 8 times 12, right? Which will give us what? 96 ATPs. If 1 FADH2 is giving us 2 ATP, 7 FADH2 will give us what? 2 times 7, which is what? 14. 14 ATPs. If 1 NADH is equal to 3 ATP, 7 will give us what? 21 ATP. Now, if you total this, 96 plus 14 plus 21 will give us what? 131 ATPs. 131 ATPs. Now, please look up. What I've said so far is this in summary. Energy yield from beta oxidation. I'm using palmitic acid as a case study. This is one fatty acid. And we know that this palmitic acid now have how many carbons? 16 carbon. Now, let's assume this is the 16 carbon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We've seen that in the breakdown of fatty acid, we are always removing two carbons in the form of what? Acetyl-CoA. We are always removing two carbon. So, if this palmitic acid undergoes the first round of beta oxidation, we'll be removing these 2 carbon as acetyl-CoA, right? The remaining will undergo beta oxidation again. We'll remove another 2 carbon as acetyl-CoA. It will be undergoing like that. We'll be removing two carbon as acetyl-CoA. Two carbon as acetyl-CoA. Now, if you notice, how many rounds did we go? 1, 2, 3, 4, 5, 6, 7 rounds, right? So we have 7 rounds of beta oxidation here. So we are having 7 rounds of beta oxidation for this particular fatty acid. Now, in this 7 round, how many acetyl-CoA did we produce? If you count it, this 1, 2, 3, 4, 5, 6, 7, 8, right? So we are producing 8 acetyl-CoA. But you agree with me that in the mitochondria, there are 3 reactions happening there. There are 4 reactions happening there. One is oxidation by NAD. So the first reaction is oxidation by FAD. For every round of beta oxidation, 1 FADH2 is produced. Every round of beta oxidation, 1 FADH2 is produced. How many rounds of beta oxidation did we undergo here? 7, right? So how many FADH2 will be generated? So 7 FADH2 is generated. Also, you know that for every round, 1 NADH is generated, right? So for 7 rounds, how many NADH did we generate? 7 NADH. Now, I said again that for every 1 molecule of acetyl-CoA that goes through the TCA cycle, 12 ATPs are generated. If we want to check, if we want to confirm this, then we'll draw the TCA cycle. Then we'll take note of how many NADH was produced, how many FADH was produced, and how many GTP. But that's not our business for now. If you want to revive that in your brain, it's on my channel. Just check TCA cycle is there. All right, now but just know that 1 acetyl-CoA that passed through the TCA cycle will give us 12 ATPs. And it is a known fact that 1 molecule of FADH2 is equivalent to 2 ATPs. It is also established that 1 NADH, when it passes through the electron transport chain, we yield how many ATPs? 3 ATPs. So now I'm saying, if 1 acetyl-CoA is giving us 12 ATPs, 8 acetyl-CoA will give us how many ATP? If 1 is 12, 8 acetyl-CoA will give us 8 times 12, right? 8 times 12, which is what? 96 ATPs. If 1 FADH2 is equal to 2 ATPs, 7 FADH2 will give us what? Will give us 2 times 7, right? Which is 14 ATPs. If 1 NADH is 3 ATPs, 7 NADH will give us what? 2 times 7, which is what? 3 times 7, which is what? 21 ATPs. Now, we want to calculate the total ATPs now produced. The total ATP produced will be this plus this plus this, right? So the net ATP, the total ATP is equal to this plus this plus this will give us what? 131 ATPs. But this is not all. You are not done. This is not the net ATP generated. Remember, the first step in beta oxidation of fatty acid is what? Activation, right? Activation of fatty acid. And for that fatty acid to be activated to fatty acid-CoA, we said two things are needed aside the enzyme. What and what? Coenzyme A and what? ATP. That activation stage, we use 2 ATP to activate. Every activation stage, we use 2 ATPs to activate. So that first step of activation of palmitic acid to palmitoic-CoA, we use how many ATPs? 2 ATPs. So if we want to calculate the net ATP we produce, we have to pay off the 2 we use at the beginning. So the net ATP generated from beta oxidation of palmitic acid is equal to 131, the total, minus the 2 we use for activation, which is what? 129 ATPs. So the net ATP generated from one molecule of palmitic acid going to beta oxidation is 129 ATPs. Do you understand this?